and we're set to go.
And I'm going to mute, so.
Well, good morning, folks. As you're joining, we'll give those who are in the queue a few minutes to join our discussion, and then we'll get started. All right, more will be joining us, I'm sure, as we move into the presentation, but we do want to start on time. Thank you for joining us today. My name is Denny Brennan. I'm the Executive Director of the Massachusetts Health Data Consortium, and I want to welcome you to our webinar today with Nth Party, an organization that is dedicated to sharing data without sharing data, sharing insights by using technologies, encryption, other methodologies that enable organizations who don't necessarily wish to share data, to move data, to store data in large centralized repositories, to share only the information necessary to perform computations that two organizations are interested in deriving from the data that they share, but nothing more than that. I will leave that to our guests today, Shireen Shermack, who's the Chief Executive Officer of Nth Party, and Andrei Lapitz, who is the Chief Science Officer of Nth Party. If we go to the next slide, I'll take you through a little bit of what's behind today's webinar and how you can participate. You will see our social media handles as well as the hashtags for the event. The event hashtags include MHDC Nth Party and Mass Health Data. Our handle is Mass Health Data. You can see Ms. Shermack's Twitter handle as SHR Cubed, and Dr. Lapitz as Andrei Lapitz, as well as Nth Party as the company's Twitter handle. All participants in today's webinar and all attendees will be muted during the presentation. Please enter your questions in the Q&A window. Current chat is disabled, so I will be following the question and answers as they come on the screen. We are recording today's webinar, as you discovered upon entering, and the video will be available to MHDC members as well as to guests within 3 business days. Going forward in 2022, we will be expanding the webinars that we present to our community, and we will be encouraging you and others to join, if you're not already members of the consortium, to consider joining so that some of the webinars that we host privately will be available to you as well. And at the end, sometime just before the end of this presentation, which we anticipate will take between 60 and say 75 minutes, I would say on the outside, we won't use the full 2 hours. Please take a moment to complete the poll that we'll set up and show you at the end of toward the end of the meeting. And next slide, Lynn, if you would please. A little bit about who we are, if those of you in the audience don't know the Massachusetts Health Data Consortium, or MHDC as we call ourselves. We are the only organization of our type in the country. We are independent and unbiased. We focus on the health data community, patients, physicians, other providers, health plans, regulators, services providers. But our goal is independence and unbiased collaboration among organizations who don't usually collaborate. We have expertise in health data standards and regulations. We have a local focus as a state-based not-for-profit, but we're also a national organization as we increase our reach and as the topics that we are experts in become topics of major interest. We used to toil in quiet obscurity, and now we suddenly find that we are working on something that everybody else is working on. We pride ourselves on invention, on innovation, incubation, and I would add to that, actual delivery. We are establishing a code mapping utility that will allow organizations to essentially map their existing codes to the required codes for interoperability and exchange. As many of you know, the US CDI and the US Core stipulate that the clinical data that is exchanged between payers, providers, and patients needs to be rendered in standards that are semantically interoperable, or as close to that as they can be. And that means that if you have ICD-10 procedure codes or CPT procedure codes in your electronic medical record, you're going to need to change those to SNOMED or the appropriate equivalent if you are to comply with not only the regulations, but the constraints and requirements of FHIR-based APIs. Next page, please. What do? We have a data governance collaborative, which really is kind of the front end. If you think of sort of where on the data continuum we sit, data governance sits at the front. Our data governance collaborative, chaired by Janice Karen, is a group of payers, providers, and increasingly members of the community, patients, individuals in small practices, others who have a stake in health data, coming together and making sure that we not only abide by the regulations, but we recognize that interoperability advances health well beyond the vision established by CMS and ONC. We are committed to data quality standardization. We have merged with the New England Health Exchange Network, and we offer exchange services, high-value X12 transactions, such as claim status inquiry, eligibility verification, benefits verification, et cetera. That is a community-governed exchange, a not-for-profit that merged with MHDC at the early part of this year. We also offer an analytics service where we provide data and analytics, including recently the Lown data on health equity and low value care and outcomes, in addition to the case mix data that we collect from multiple states in New England. Our webinars are private and public. We have a Vantage Point series that we pride ourselves on interviewing leaders in health data, people who have been in the business for a long time or have done things that are extraordinary. We want to know more about who those people are. We know what they do, but we want to know about who they are and why they do what they do. We have our forum, which is really the CIO, CTO, CISO, CMIO. The number of acronyms for executives who deal with information has grown considerably. And the forum is dedicated to those individuals across the healthcare ecosystem who need to understand the new regulations, the impacts that this will have on their organizations, and increasingly the role of the person, the consumer, as we call them at times, but the individual patient in governing how their data will be used and how their data will be managed. Lastly, we pride ourselves on hosting what we consider some of the best webinars around, and we consider today's discussion to definitely be in that category. So I think that covers it for us as far as MHDC is concerned. Andre and Shireen, I thank you for your patience while I went through the iterations of what MHDC is and what we're about, and I'm pleased to turn the meeting over to you.
Thanks. So today we're going to cover unlocking insights without sharing data. And we'll do that by discussing privacy enhancing technologies and the future of patient privacy to make it applicable. So we'll run through these topics. What do we mean when we say sharing insights, not data? Andre's going to take you through data clean rooms versus privacy enhancing technologies, and he'll walk you through how to compare or think about comparing pets, solutions, and vendors. And then we'll talk about how they are an opportunity to improve patient privacy. So as was told, I'm Shireen Shermack. I'm the CEO and co-founder of Nth Party.
I'm Andre Lapitz. I'm Chief Science Officer and also a co-founder of Nth Party.
And we'll be your hosts to walk through this today. So just to give you an idea of where this comes from or where we come from, Nth Party was really put into place as a means of commercializing multi-party computation that had been developed by Andre and team at Boston University between 2015 and 2019. The research and development of the early libraries was via an NSF and IARPA grants. And there was a lot of investment made in a lot of open source libraries for multi-party computation, but there was clear demand by industry, including, fintech, ad tech, and health tech, for taking this technology into market and solving some real problems. There were production deployments of privacy enhancing technologies at over 100 organizations through one of the major projects that got this all started with the Boston Women's Workforce Council, which gathered very sensitive wage data from companies all over Boston in order to be able to contribute that data for analysis for gaps in by gender and race. Companies really wanted to be assured that they were going to have a completely private interaction and that their individual data would not be able to be discovered later. So this technology, or the original versions of this technology, were created by Andre and team to really serve that purpose. By 2020, we took this out of the university and started Nth Party. We really focused heavily, at least initially, on ad tech as a space for, it was already in disruption. You read about what's going on with Google and with Facebook and data, and you understand that we did not have to disrupt the space as an early stage company. It was already in major disruption, and we were just walking in with a potential solution. So, we see a lot of demand for overlap testing, analytics, enrichment, to create more privacy enhanced workflows. And one of the key differentiators of our team is the browser-based versions of the software that were created to make things really easy for folks to submit their data in an encrypted way for the wage gap analysis. And that has become a real differentiator as folks want to make it as easy as possible to collaborate. And if you can do it quickly and through the browser, there's, you can create interactions that are as easy as paying a parking ticket. Just because the technology itself is so sophisticated. In the future, we see lots of new workflows and application domains that this technology could be applied to, particularly in healthcare, because it allows parties to collaborate without moving their first-party data. And it certainly addresses gaps that are not handled by the current offerings of clean rooms.
Shireen, I have a question I wanted to ask.
Sure.
Just the term clean room. Could you just talk a little bit about, all of us think of, level 5
Right.
labs, or we think of, semiconductor manufacturing, or places where, where they're building a satellite and everybody is absolutely, sealed up and the environment is sterile. But could you talk a little bit about that in this context?
Yeah, this does not require Tyvek suits or anything of that nature.
That's good.
Yeah, I mean, most of the references to clean rooms, especially in the ad tech space, but also to some degree it's creeping into healthcare, is the idea that there might be a neutral third party whom both sides collaborate with, and that third party does the computation. But honestly, this slide, which helps explain the difference between clean rooms and privacy enhancing technologies, I think will clarify what we're considering a clean room. So I'll leave it to Andre to roll with that.
Yeah, actually, coincidentally, most of this presentation is intended to answer that question. So we'll certainly expand on
Thank you.
this brief answer. Yes, as this slide indicates, we do try to distinguish, and this is something that customers looking at vendors of clean rooms and other privacy technologies are probably going to have some trouble today just because of how much noise there is out there. There's a lot of terms being thrown around, and there's a lot of conflation between concepts like clean room and privacy enhancing technologies. So we really want to emphasize this, and sort of the rest of this talk isn't really about Nth Party. It's really meant, as the agenda indicates, to sort of help everyone who's watching this help navigate and compare options and vendors in this space. And in the same vein, this slide is trying to sort of first distinguish these two major concepts. So clean rooms can be either traditional, or they can be more contemporary or modern or future forward, kind of however you want to say it, if they incorporate some privacy enhancing technologies. So I'll answer the question first by answering the question about traditional clean rooms. So traditional clean rooms are a metaphor for typically an actual organization or location. It's a location where a server or some other IT infrastructure might be present, that is trusted, and that will house for the duration of some workflow sensitive data from typically 2 or more organizations. That's sort of a traditional clean room, and there's many vendors out there today that offer that. You could also just use standard data warehouses in that way, as long as you trust them and are comfortable sending your data to them. And then there's the distinction between that and privacy enhancing technologies, which, as we'll see in a second in the subsequent discussion, they could be used as part of a clean room, or actually they could completely obviate the need for a clean room and remove it from the equation. So hopefully we'll be able to illustrate that. But to sort of briefly speak one last time about Nth Party, Nth Party doesn't view itself as a sort of, as it says here, a SaaS platform or a clean room vendor. We view ourselves as a vendor of privacy enhancing technologies that come in the form of software and that we license. We could license it to a clean room vendor. We could license it to, in the case of ad tech, we can license it to brands or agencies or intermediaries. And likewise, in the case of sort of the healthcare data ecosystem, there are companies, that, for example, Datavant made a recent announcement that they were looking into privacy enhancing technologies. So certainly this kind of technology can be licensed to organizations in the health space as well, who are looking to either enable collaboration using data sets from multiple sources, or to actually, if they have enough clout and if they're large enough and they're first party data holders, they could probably impose that their partners use these technologies to interact with them. So certainly, as the space matures, there will probably be more companies that are like us, that license software and allow large organizations to integrate that software to have the benefits of these workflows. But there certainly are already and will continue to be many both traditional and sort of clean rooms that employ privacy enhancing technologies. So all of this, if it's a little much, it'll make more sense as we go through the next slides. So does that answer the question, Denny, that you were asking?
Yes, I appreciate that. And I appreciate the fact that I'm answering a question that you're about to answer in great detail. So
Yeah.
I'm going to test my questions more carefully before I ask.
It's okay. Well, yeah, I mean, it's fine. It's a good, it certainly is better than if it were the other way.
True, I agree. I have no problem asking dumb questions.
Yeah. So, so in order for us to talk about the distinctions that I was making in a bit more of a concrete way and to be able to refer back to something, I just put together, this is, drawn from more of an, again, we're in an ad tech space, but we tried to kind of take away any of this ad tech specific pieces of this just to have an example workflow that we can reference when we're talking about privacy enhancing technologies, so that we can compare them to each other, as well as compare them to the sort of traditional clean room approach that I mentioned before. So the workflow on this page that's illustrated here is fairly simple. It involves 2 organizations. Again, depending on which domain you're in, in our space in ad tech, where we've been focusing, this could be something like a brand, and then something called an identity graph vendor. So it's an organization that may have information about consumers, and it helps brands learn more about their own customers, for example, by augmenting data that the brand might have. And you can certainly imagine in the healthcare space sort of a comparable workflow that might exist, where a provider or even a sort of a pharmaceutical company, if you're advertising to doctors doctors, for example. They would have some data set of an audience, and they would want to learn more about that audience in order to target it better or to enable some kind of subsequent workflow. But in any case, the purpose of this is just to say and kind of articulate some of the desires that these parties may have in the way that data is used and protected when they conduct, here there's two kind of variants of a workflow. One is taking these two data sets, the first party data owner's data set, and then some kind of vendor data set that has more information, and maybe doing an aggregate analysis. So that's kind of the top right result up there. Or maybe doing a specific analysis that actually gives you row level granular data. And of course, there's many things in between where, as we'll talk about, the results may be de-identified or they may be differentially private. But this kind of two extremes is going to allow us to make some distinctions later when we're trying to compare these things. And then I've articulated here some below these two parties, some stipulations they may have. So for example, the first party data owner may say, I want to disclose as little as possible to the second party. And we'll see, with contemporary technologies, that may be as little as nothing. You could actually disclose nothing. But in this case, let's just say they're trying to be responsible with their first party data. They're trying to protect, let's say if it's patient data, individual patients. So they want to disclose as little as possible to the second party. But of course, the first party here is, in this scenario, kind of the customer. They are expecting some kind of useful outcome from this transaction. And so they are expecting to see some kind of results at the end. The second party may have, in this scenario, I imagine when I put this together, that the second party has maybe a much larger data set. So there's a lot more liability associated with the data that they have. So they also want to obviously protect their own data. But in this transaction, they're really interested in seeing as little of the first party data as possible as well, because they don't want to increase their liability and have to deal with even more data that they're responsible for. And so these are the constraints that they may have. So the first thing is to just go back to traditional clean rooms and say, if there is a third party that's not one of these two parties that both of them trust, in a way you can solve all of these problems. You would just have these two parties take their data, send it to a third party, and that third party could conduct the workflow, produce the result that we're seeing here on the right side, and deliver it to, in this case, if it's the first party that's the customer, and deliver it to the first party. So that in this breakdown that I have, that's sort of presented on this slide, that's the left-hand column here. So there's a trusted third party. The third party just takes the data in the clear, conducts the workflow, and returns the results back to whoever is supposed to receive them. And this solves the problem. You could just stop right there. You've got your traditional clean room and the two parties are satisfied. But this is where the privacy enhancing technologies start to get interesting and where you can start to distinguish between them. So the introduction of this third party introduces an additional constraint, or at least a question that wasn't present before in the original scenario. Here, there's only two parties and you either do or do not disclose data to one another. Once you've introduced that third party, now you have to ask your question. In both parties, both the first and second one have to ask this question, how much of our data are we willing to disclose to this third party? And it may be that the third party as well wishes not to see anyone's data, because again, it increases their liability and therefore their costs. So privacy enhancing technologies at a very high level give you two other columns that you can have here, the two that's in the one in the middle and the one on the right. So one variant is that the third party remains, it continues to exist. And there's many reasons why this might be beneficial, as sort of these two bars here indicate. It may be that the third party has other value added features in their offering, so that they are able to have domain specific analytics, maybe visualizations, maybe they coordinate all these things and allow all these different data owners to come together in a marketplace. There's many reasons why a third party might be beneficial, but that third party could implement their entire operation in such a way that they don't have to be trusted using these modern privacy enhancing technologies. So the extreme version of that is that the first party and the second party do send their data to the third party, but the third party can say, I cannot decrypt it, I do not have the keys to it, but I will conduct the workflow that you all want to sort of effect, and I will deliver an encrypted outcome to whoever is supposed to receive it. And the only thing they'll be able to do is decrypt that result that everyone agreed upon at the beginning of the workflow is what the recipient should receive. So that gives you sort of this option for this third party to essentially also not see the data and satisfy these requirements that we had for the first two parties, as well as the additional requirement that the third party shouldn't see the data either. Now, of course, the third party may not always be desirable. A third party will introduce costs into the equation. They have to operate infrastructure, they have to exist. And in many cases, these technologies could actually remove the need for a third party completely, and that's the right-hand column. In those cases, you could have a situation where the first and second party simply run software, and the software, excuse me, interacts just via communications protocols. Excuse me. And the data that's exchanged between the two sides is always encrypted data up until the sort of final outcome when the results are decrypted. And again, the keys to decrypt that data are not present on the other side. So even though the second party may see encrypted data from the first party, they do not have the keys to decrypt it. And that's a very important distinction from data governance solutions. So I'll briefly mention sort of that. There's a couple things here at the bottom about these technologies, but one of the important things is that what we're talking about when we talk about privacy enhancing technologies is not data governance or access controls. So these traditional techniques wherein data is present, possibly in encrypted form somewhere, but in order to actually run a computation to produce a result, you need to decrypt that data for at least some amount of time. That's not what privacy enhancing technologies do. So in most cases, privacy enhancing technologies to some extent will keep the data from all the way from obfuscated all the way up to completely encrypted in a way that cannot be decrypted throughout the computation process. And that really distinguishes it from these kind of data governance solutions. Nevertheless, data governance is complementary to these technologies, because even just the basic question of what results should be viewable at the end when everybody runs the computation on encrypted data and now the result can be decrypted, that's a data governance question. That's not a question that that these privacy enhancing technologies can answer on their own. So data governance is still an important feature. And that's why, for example, you may want to be in the untrusted third party scenario rather than the sort of no third party scenario. Someone needs to take care of the infrastructure that does things like governance and so on. But the point is that there is a distinction between those sort of privacy enhancing technologies that we're kind of talking about today and the sort of traditional governance and access control techniques. I'll actually just ask Denny, is there anything you'd like to kind of raise about this, or should we keep moving on?
Well, I'm intrigued about, and again, fearless about the quality of the questions I might ask, but I'm curious about how people work with encrypted data that they don't have access to, they can't access it. I mean, if I have an untrusted third party who is going to handle encrypted data in some manner that I need to control, how is that party going to be able to do that? I mean, again, I'm asking probably one of the killer questions, but handling encrypted data strikes me as, having a bunch of locks in your hand without any of the keys. And, how does one go about, unlocking that without, opening the door and letting things get out, or whatever the risks may be? Could you talk a little bit about that?
Yeah, unfortunately, we didn't prepare a slide for some examples. So I'll try to verbally describe two common ones that should be pretty easy to describe. So a lot of these technologies to some extent rely on cryptographic primitives, some of them ancient and some of them more contemporary. And the primitive operations are often very, we're familiar with them from probably even elementary or middle school in some cases. So I'll give one example, which is if audience members remember the distributive property of addition and multiplication. So one thing that you could do if you have, let's say, two numbers like 5 and 7, is you could multiply both of them by another number like 10, let's say. So if you have 5 times 10 plus 7 times 10, if you add them up, you get 5 plus 7 times 10, right? So if the operation of multiplying by 10, we pretend that that's encryption, right? If we're encrypting something by multiplying by 10, then you can imagine that by encrypting two values, 5 times 10 and 7 times 10, We now have two encrypted values, 50 and 70, but we can still add them. You can still do useful work, even if you don't know that the original number was 5 and that the way you encrypted it was multiplied by 10, because maybe you did it some other way. Maybe you had the original number was 2 and you multiplied it by 25 when you encrypted it. So when you look at that 50, if you don't know what the original data was or what the key was, which is 10 here, when you look at the number 50, you can't actually be sure where it's coming from. But nevertheless, you can do useful work. You can do 50 plus 70 and you'll get 120. And you'll notice that is in fact 7 plus 5 encrypted using 10, because 12 times 10 is 120. So then you can certainly take that result, which is 50 plus 70, which is 120. You can hand it off to someone and they can decrypt it using that original key of 10, and they'll get a useful outcome, which was 12, which was as if you had added 5 plus 7 and achieved 12. So that's really, what I just described is one of the ways that multi-party computation, one of these technologies, is implemented, except that instead of using, as I used, integers and sort of basic arithmetic operations, you use slightly more complex operations. But the algebraic property that I described is exactly the one that's used. And its more general name in mathematics is called a homomorphism, and that's where the name homomorphic encryption comes from. And so hopefully that illustrates one way in which it's possible to do something useful with two encrypted values for which you do not have the key, but you can still do things like addition and produce an encrypted result that's meaningful once you decrypt it. Another example that's very common, and this is one that's used for this kind of overlap analysis, which is very common. Maybe you want to check two patient data sets and see if there are any common rows there, is something called commutative encryption. So traditionally, when you encrypt something, you can encrypt something twice, right? You can encrypt something with one key and then a second key. But traditionally, when you do that, what you can't do is you can't change the order of the keys after the fact. So typically, and this is also true about hashing for anyone in the audience who's familiar with hashing. So with those traditional techniques, I take my patient data, I encrypt it using key A, and then I go off and I encrypt it using key B, and now I've got it doubly encrypted, and that's what I'm stuck with. With these technologies, there's something called commutative encryption that allows you to change the order of the keys while still kind of moving and working meaningfully with the data. So let's just kind of go back to this example. One way to affect this transaction, this kind of transaction, without actually involving a third party, is to have the first party encrypt its data using the first party key. I'll call it key 1 for to be a little more close to this diagram. And it can actually, party 1 can send its data encrypted using key 1 to party 2. Remember, party 2 doesn't have key 1, cannot decrypt that data. But what party 2 can do is it can encrypt that data that's already encrypted coming from party 1 with its own key 2. So now you've got a data set that's encrypted 2 layers, key 1 and key 2, that's coming from the first party. And then the second party can take its own data set and encrypt it using key 2 only, because it has its own key 2, right? So now what you've got is the first party's data encrypted using both keys, key 1 and key 2, and then you've got the second party's data encrypted using its own key 2, and nothing else. If it sends its data back to party 1 now, party 1 can remove its own key, because remember, it doesn't matter, order doesn't matter anymore. And what party 1 is left with is party 2's data encrypted using party 2's key, and its own data encrypted using party 2's key. So now party 1 has comparable data encrypted using the same key, but it's a key it does not have. So I apologize, I don't have this in the diagram. I wasn't prepared to go through this particular example, but hopefully for those that could follow, it kind of illustrates how party 1 can end up with, just as my example with 10, can end up with 2 pieces of data that are encrypted using the same key, but it does not have the key, and so they cannot decrypt it. But once you have data encrypted using the same key, everything I said before applies. You can start doing operations on data encrypted using comparable keys without actually decrypting it. So those are all very simple examples that obviously sweep a lot under the rug, but hopefully that gives some example of and some credibility to the idea that you can actually do useful operations on data even though you don't have the keys.
Oh, it's very helpful. Thank you. I appreciate that.
Great. So, the purpose of this again was purportedly to kind of help navigate the space when you're kind of looking at this, and hopefully this breakdown already starts to provide kind of some landmarks for what kind of questions you may ask when you're evaluating a technology or a vendor. because it's a very natural thing to ask a vendor, all right, so do you behave as a trusted third party and you see my data in the clear? Or are you behaving more like an untrusted third party and you don't need to see my data in order to provide your service or to enable the transactions that I would like to do with my partners and customers? Or it'll probably be fairly evident if it's in the third scenario, but it's still good to be able to recognize that some vendors out there may be able to offer you something that you can just integrate into your own platform or infrastructure, and you don't actually need to have subscription costs associated with what you want to do with your partners or customers, particularly subscription costs on both sides in some cases with some vendors.
When we're out talking about our I was just going to say, when we're out talking about our software, people don't feel educated enough to ask intelligent questions. And that previous slide is something we share with them just so that they have some sort of framework to understand what choices they're making when they choose a different solution. So, am I going to be disclosing to a third party, and, all those other types of questions. It's interesting because it's such early days for some of this that they don't feel confident they're asking the right questions. So I think it's, this material has been kind of useful in just educating the space a little bit so they can feel more confident in making choices because they really have to soon.
Yeah, absolutely. And this is something that, as the vendors out there also start to interact with a more educated audience, they'll be forced to be a little bit more clear about, for example, it doesn't have to be this taxonomy that we came up with, but something similar to this must exist because these distinctions exist. And vendors will have to start categorizing themselves a little more clear. Again, there's not, as I mentioned, there's advantages to having these models and disadvantages. And so there's no reason to have any one of these be the end all. Be all, but at the same time, hopefully vendors will start to communicate more clearly into which category they fall as well. And this set of questions here and on this slide is really meant to kind of, here's some issues you may want to address internally as you're evaluating a vendor or choosing a vendor. And they kind of relate to this, kind of key question, which is what's the extent of disclosure to the third party? Once you introduce a third party, you have to ask this question, right? How much do I care that the data is being disclosed? And there's reasons why you may or may not wish to disclose data to a third party. Typically, the third party has different kind of constraints associated with what it's doing. Now, sometimes it may actually be better suited to ensure that you're engaging in these transactions in a manner that complies with regulations. In some cases, not. So, it's important to sort of make the list of what the reasons are that you would like to protect your data from both the second party, if you're the first party, as well as the third party, and then sort of take that into account when you're evaluating vendors. And the other issues that will come up, and I'll try to, as we kind of get into those technologies, talk about some of these, is there are other dimensions that are impacted by the use of privacy enhancing technologies and even the choice of privacy enhancing technology with respect to things like cost and scalability. So you may choose to have a vendor help you that does not use the latest, most contemporary, strongest form of encryption, simply because your data sets are in the petabyte scale and those technologies are not ready yet to handle petabyte scale workflows, or maybe a very complex workflow, like you're taking MRI images and you're trying to build a machine learning model. In some cases, certain privacy enhancing technologies will be better suited to handle that than others. And that's something that you may also incorporate into your decision making when you're choosing a technology or a vendor. So
we have Andre, we have
sure.
a question from Michael Boland who asks, first, he thanks you for the example of performing analysis on encrypted data, but he asks, is there a reference that describes the kinds of analyses that can be performed in this way? Would you guys recommend some key texts or articles that might, help inform members of this audience and others as to sort of how this developed? And there we go.
Yeah.
Right.
So,
never mind. I think I have a psychic gift that I was unaware
of.
Today.
You're going to earn a very high score today, Denny.
Either that, or we have just a million slides in here.
Yeah, that's right. That's right. That's the other possibility.
So some of these are maybe won't exactly answer that exact question. These are probably more kind of landscape, how to, similar to the format of this talk. But to answer, just sort of two ways to answer that question, or two answers to that question. So first of all, the general answer is, it is possible to do any kind of computation on encrypted data. And there's a number of ways that you can do that. And I'll get into them in a second when we get into the beefiest slide in this deck with lots of details in it. And I'll talk about sort of those various ways. But it is certainly the case that it is possible to run any computation on encrypted data without having keys. Now, in terms of how that can be done, there's different levels of publications and sort of, textbooks are being written. Typically, if you want to find a textbook kind of chapter about this stuff, they're probably being written right now, or maybe they're in some kind of cryptography textbook. There's certainly academic papers describing various protocols. Our own team, for example, back at the university, we put together open source libraries that exist out there, and they're certainly not production quality, in my opinion anyway. But certainly you can read the papers about those libraries and sort of read it at that academic sort of level of detail and see how these things work. Hopefully the pointers on this page do, if you click down through a couple of links inside these documents, you'll be able to find different levels of sophistication with respect to the explanation of how it's possible. So everything from sort of the picture versions of the verbal descriptions I gave, all the way down to here are the actual names of the cryptographic primitives and protocols. Here's elliptic curve 255.19 and its points and its scalars, and here's how you do it. So depending on what level of detail you're interested in, there's lots of materials out there. Hopefully this is a starting point. We're happy, of course, if someone asks a more detailed question by email or something like that. We're happy to provide additional information that might help find the level of detail and the level of technical, sophistication of an explanation for how a workflow could be conducted on encrypted data.
But Andrea, I've heard you say many times, think about the range of SQL queries, and most SQL queries could be done using this methodology, which I'm not sure if that's what the questioner was thinking, but
yeah, certainly. Typically, and this is our own products that we offer as Nth Party. Typically, what we try to do is we try to offer products that are scalable, that our customers can actually use, and for that reason, where the technology is today is if you're doing what I call a fairly shallow SQL-like query. And what I mean by fairly shallow is, in the sense of you could think of it as the length if you want. When you write down the query, how many operations does it have? Is it something like, maybe there's a join followed by a filter, or maybe there's a sum, or maybe a filter sum, filter join sum. So if it's just a handful of maybe 5 operators arranged in some order, it's typically the case that you can implement a privacy enhancing workflow on encrypted data of that kind with relatively manageable overheads, all the way down from it's basically still going to be linear with maybe some kind of constant factor cost associated with it, to, depending on the number of parties and as you get into the 5 operator sort of space, maybe it'll be fairly costly, and you're going to be at most able to do tens of millions or hundreds of millions of rows in that workflow, and may take a few hours depending on how much parallelization you want to do. So that's kind of the range where it's at. One of our most common products, we typically quote performance overhead just a performance of being able to do about 1 million rows, to encrypt them or to process them as part of that query, about 1 million rows in 10 seconds. So it's not sometimes instant, but certainly these technologies are scalable and useful in real world scenarios today. And there are vendors with all 3 models here that I've shown, or I guess 2 if we just talk about privacy enhancing technology, the 2 on the right here. There's vendors out there like us and others who will help you run those kinds of workflows on encrypted data. Great. So I'll try to kind of get into this slide to some level of detail here, but obviously this is a very busy slide, and we realize that. But it's in some ways it's necessary as well, because it does help map where all these words that you see out there on vendor websites and white papers and documents, and you're going to be seeing a lot of these words if you're not seeing them all the time already. over the next several years, where they actually fit in, in at least this kind of diagram that we've created with these 3 columns. So you'll notice that I took the original diagram up here with these 3 columns and kind of pushed it up to the right-hand corner. So hopefully you see that correspondence here. So this is that same 3-column diagram, but a new dimension has been introduced here, which is the distinction between not disclosing the data while something is being done, while the workflow is still running, while the results aren't ready yet, while you're cooking it, so to speak. And then there's the stage at which you want to disclose the results to the recipient to achieve the outcome that you're looking for. Someone needs to make a decision. Someone needs to learn more about their patients. Someone wants to learn the results of the trial, et cetera. And we're distinguishing between those 2 stages because these technologies are intended and designed and capable of addressing, in many cases, only one of these stages. And it's important to understand that because, as you'll see in a second, with you'll notice some of these are duplicated. There is some there's some funny games that vendors are playing for justifiable reasons, but nevertheless that cause confusion for those who are trying to evaluate vendors and look at which technologies they may want to use. So let me start at the bottom here and talk about sort of data disclosure. So there's a long history now, decades long, of techniques that exist to protect data at the point of disclosure. And when I say protect data, I mean protect the individuals that are involved in, or that data relates to. So for example, individual patients. So you may want to publish the results of a trial, for example, but you may not want to publish the results in such a way that individual patients can be identified as having been in the trial that led to those aggregate or other types of results. It could even be obviously row level results, but you just don't want to publish their names, right, and their demographics or something like that. So these techniques have existed for a long time, and some of the ones that are listed here in red are well known and they're out there. The one thing to be careful about these techniques is they have existed for a long time, and also for a long time now we've known that there are ways to get around them. There's things that if you want to look up the mosaic effect, where sometimes you can identify an individual by if you just have 4 geographic locations that a person visits on a daily basis, you can identify something like 90% of all people in the United States just using 4 geographic points. So you don't need a lot of bits to individually identify someone. So typically a lot of these techniques, it is still possible to use them safely if you know what you're doing, and this is where vendors can obviously help with that kind of thing. But at the same time, the honest thing to say about them is they're not always future-proof, in the sense that there can be innovations in the future, particularly machine learning innovations. We see this a lot in recent times, that will be able to overcome these techniques. So volume of data and sophistication of machine learning algorithm, for example, may be able to reconstruct information that we previously thought would be hard to reconstruct, but actually it turns out it's easy to reconstruct. But the point is that if you need to publish the results, you need to publish the results in a meaningful way. So you may need to use these techniques. Differential privacy is one of these techniques that's actually is very rigorously, or sort of the privacy and disclosure, sort of extent of disclosure is very rigorously defined in differential privacy, which is why, at least in this page, we've chosen to categorize it in our editorializing kind of manner here as cryptographic, because there's a high level of rigor in differential privacy. But it's still the case that differential privacy is fairly difficult to use. There's something called the privacy budget. You need to think about, for all future history, how many times will people run this query again on the same data? And that's obviously a very hard thing to budget for. So you kind of just have to make compromises in that respect. But the point is that these techniques, they're there, they solve a specific problem. You have to understand the risks, but you're going to have to use them if you want to disclose results, because they protect individuals when the results are disclosed to the receiving party. Now, what I want to kind of get into is, now that we've established that there's a set of techniques for sort of safe disclosure and that it's fine, is how these are used to address the clean room problem of the third party. Because this is where the confusion begins today, and this is where hopefully we'll try to help you navigate through that potential confusion, using this framework that we have here. So in many cases, when you have vendors acting as an untrusted third party, you will find them using these red techniques here in order to protect data from themselves. So basically they say, for example, okay, first and second party, minimize what you send to us, de-identify it first. Maybe we'll even help you de-identify it, or maybe you'll send it to us and we'll de-identify it right away to, make promise not to look at it before we do that, for too long. So there's vendors that will do that, and there's legitimate reasons why vendors are doing this. Some of them are the vendor just simply isn't familiar with the most contemporary technologies, and they've been around for a while, or they started the business a few years earlier. And they're offering something that does add value, and as long as they're not being misleading about the limitations of these technologies, then it's perfectly fine to do so. Another reason is that, as I mentioned, some of these other technologies like secure multi-party computation and especially homomorphic encryption, they have performance overheads that may not make it possible to do certain workflows just from a feasibility and given the data scale perspective. But it's important to understand that the limitations and sort of drawbacks of these techniques apply in this case as well when you're using them to protect data from the third party, and are actually potentially even worse, because when you're just using these techniques to disclose the result to a single party that's receiving the result, that's one thing. But when you're using these techniques to protect data from a third party that sees everybody's data at large volumes from many different sources, that third party actually now can reconstruct probably a lot more information from data protected using these techniques than sort of the individual recipient may, depending on sort of, again, there's always exceptions, but typically these platforms are centralized sort of storage spaces for a lot of data in many cases. So the important thing to understand about the new technologies, the things that we have kind of in blue here, is that these technologies don't have those drawbacks. So the particularly secure multi-party computation and homomorphic encryption are pure software, you don't need hardware, versus the trusted execution environment approach, which essentially has the same guarantees but requires specialized hardware. These techniques don't have these drawbacks in the sense that there will not be, in some cases, any invention in the future and any form of math that will ever be created that will make it possible to decrypt data that's encrypted using a secure multi-party computation protocol during the time that it remains encrypted and you don't have the key. So in some cases, these techniques are absolutely future-proof against any kind of new innovations in the future. In some cases, quantum computers are really the only threat, or anything like quantum computers that essentially will render all traditional end-to-end encryption that uses certain protocols useless as well. But for the most part, these are much, much stronger techniques. We're not just removing some data, we're not just hiding some of the information or masking it or adding noise to it. It truly is as encrypted as your communications between you and a vendor when you're making a credit card purchase. The telecom company that enables that transaction between yourself and your vendor does not see your credit card, and this is the same level of protection that is offered by these technologies in blue over here. And then the other feature of these technologies in blue that is unique to them relative to the ones in red is that they can eliminate the third party potentially completely, right? And this is what I was talking about before. So the red techniques really, for the most part, aren't really going to help you with that, unless you just basically, exchange data that's protected, de-identified, which is quite common today. But it doesn't give you anywhere near the level of protection that these techniques do, even if there's no third party involved. So you really could end up right back in this situation here with two parties, but because they're encrypting the data and they don't have each other's keys, you've effectively been able to do that entire workflow using these techniques like secure multi-party computation without involving a third party and without the necessity during the sort of the computation process of de-identifying, et cetera, the data. It's just fully encrypted the entire time until the result, and then whoever you agreed upon at the beginning is going to be able to decrypt that result. They have the key to that and they decrypt it, and that's kind of the end of that process.
So just a question on the less secure and, given machine learning algorithms, the potentially breakable encryption that you've identified in red. Today we have a number of health systems, for example, providing data to a third party that they want to make available to pharmaceutical companies, or they want to get it back in order to develop better machine learning algorithms for treatment of particular patient populations. We have Ascension, the largest private not-for-profit health system in the country, sharing data with Google both for the purposes of encryption as well as for, I think, a number of other data-related enhancement techniques in order for Ascension to be bringing those data back in, create an ecosystem of companies who can use those data encrypted to do a number of things. We also have Truveta, which is, sort of a Microsoft offshoot, where a number of health systems have done the same thing. They've said, we're going to give you our data. We want you to encrypt it. We want you then to make it available in an encrypted form to pharmaceutical companies. And we have the Mayo, where John Halamka, a close colleague and friend of MHDC's, and many of the folks in this room, doing an even more sophisticated form of sharing data, containerizing the real data and separating the encryption from the actual computation. But all of those sound risky, especially the first two, given what you've just described, Andre. In a future, we could envision, and I'm leaving out the patient permission or the patient's right to say whether you can use my data or not in this purpose. That's an entirely another discussion, and one that we're, as a consortium, very deeply involved in. Putting aside whether this is the most ethical way to do it or the most, proper way to do it, it also seems that it has its risks, and these organizations should be thinking about how do we differentially encrypt our data and not rely on these third parties who, as intermediaries, may be the fox minding the hen house. They're both aggregating. They can see my data. They can peek at it. They're aggregating it. They're encrypting it, but it's a little too close for comfort. And it seems to me that these computations would enable health systems who do want to build better algorithms, who do want to have health data available, ideally with the patient's permission, because of the true provenance of the data is the patient, putting that again aside for another time. But it sounds like this would be a much wiser approach for these organizations to take, rather than let's give it to a third party, trusted or untrusted. In this case, it's untrusted, I would say, and have them do all the work and bring it back to us in the form that we need it, or make it available for third parties to use. Could you comment on that? I mean, shouldn't we be encouraging the industry to move away from that kind of data sharing model to one where the level of encryption and the level of third party involvement is reduced to as close to zero as possible?
I mean, certainly we can be idealists and yes, say that would be, certainly as the technologies mature, and to be fair, they weren't mature enough, 10 years ago for this, even 5 years ago. As Sreen mentioned, our use case that we did back at the university was novel. It was the first of its kind, certainly with respect to sort of our browser and accessibility capabilities that we were able to deliver sort of in that manner. So to acknowledge sort of, we don't want to oversell this, right? The technology is fairly recent, and so we can't blame anyone for even today being skeptical about this idealist view of let's move everybody to this technology. I think there's also kind of another way of not overselling this is the cat's out of the bag in many cases, and as a result, it's probably going to be hard for large organizations to, once they've already established the business relationships and the trust relationships and the regulatory relationships that they already have with one another, to claw that back and also pay the extra cost of using a new technology. So at least we as a company, sort of the way we view this as sort of a way that is reasonable to move forward, is to look at the places where someone is looking at new things they would like to do with data collaboration or data aggregation or joint analytics, and they're nervous about it and they're not sure if they should do it. They see there may be a benefit to doing it, but as you described, they don't want to take the risk. I think this is where this technology can come in today and say, hey, look, you can actually get the benefits you're looking for. You want the outcomes and you can achieve them, but the things you're worried about, you can eliminate that. You won't have to worry about those things anymore. You'll still have to worry about whether the outcome leaks something, and that's fine, but that's what you want, right? You want that outcome. You want that result to be able to analyze it or take action based on it. So that's worth it from your perspective. But all the other risks associated getting to that point can be eliminated using these techniques, and that's probably the place to start to get adoption. ideally, once we gain practice and vendors become more and more sophisticated, and by the way, just be very fair, there's a vendor out there called Triple Blind that uses secure multi-party computation, and they have I think a Mayo Clinic pilot that they've done. So there's other vendors out there who are doing this with real healthcare data. But the point is that as these vendors get more experience, and this is something I would say to the organizations out there, I think it's actually in a slide later in this deck, those vendors aren't going to be able to come to you with the best solutions for what you need unless you engage with them earlier. Because we as a vendor have this challenge, right? Unless we have customers who are willing to, yes, to a certain extent, take a risk on the potential of a new technology and help us build something for them that actually matches their use case, it's hard for us to predict. We don't all have Denny's gift. We cannot predict what the questions are going to be that that the customers need to answer in order to actually implement this technology in their use case. So we certainly encourage anyone out there in a position to do pilots with these kinds of vendors, not just us, to take that risk, and yes, maybe even a little bit of cost, because that's the only way we're going to get to a point where, with these new scenarios where you're maybe a little nervous and you do see the value of this, we'll bring the technology to the point where it'll be essentially obvious and much easier to just go back and claw back all the risky things we're already doing. So that's kind of the editorial answer to that question, and hopefully a diplomatic answer.
It was a good one.
Yeah. So obviously you could get even deeper into this slide. Again, we're happy, I think, if anyone has questions where we can help give pointers to anyone about any of the terms on here. We would always be happy to provide additional information and point to others who can provide you maybe even better information than we can. But I guess now we can kind of change gears a little bit from that and maybe just kind of remind and review what we've talked about in a context that hopefully is more closely aligned with what the audience is familiar with on their domain, and talk a little bit about the opportunities and how to think about it.
Yeah, I'm kind of curious. I mean, please, to the audience, please post your questions, because we want to make this as relevant to patient privacy as we possibly can. But here's some thoughts that we wanted to wind down with, which is, the patient privacy is moving far beyond like opt-in and opt-out types of governance frameworks. Owners and contributors of data can decide at the point of encryption or at the point where computation needs to be made what's possible at all hops. That's what this technology makes possible. It makes risk reduction and liability reduction possible. So sometimes that's a really good motivator for people to understand or to go out there and do some exploring on what this type of technology is capable of doing. But I would say about half the time when we're talking to folks, it's because they have some risk concern that they want to bring down. And a large part of that is because data can't be reused. You can't ask more questions of the data without the consent of the contributors after the fact. This removes, as Denny, as you made the point, removes the need for big centralized pools of data in order to be able to do computation. So, for governments, even the military, who may need to have centralized or think they need to have centralized data warehouses, it's possible to decentralize that information, but still be able to come up with a list of what's where without, creating something that becomes a tempting target. It's complementary as things move towards interoperability. I know MHTC is doing their part in trying to consolidate data formats. This is certainly true in advertising tech, but in health tech, there's just a whole bunch of other Rosetta Stones that need to be created. But, using these types of techniques, you don't have to strip out the matching components, the PII. So it makes it easier to move towards interoperability. And then in terms of precision and accuracy, as Andre was saying, some of the other techniques can involve adding noise or can involve, you know, grouping things together in the beginning in order to preserve privacy. But this technique, multi-party computation, allows for granular results and granular computation because you don't have to remove or add noise to the data. It's just being maintained at the row level. So there's no risk of exposure beyond what was a pre-agreed output. So I know, Andre, do you want to enhance that, or do we have some questions?
Yeah, I mean, yeah, just to kind of reiterate that, because I think maybe we didn't emphasize it enough during the previous discussion, that these techniques, the ones here in blue, they allow, as we've all been saying, the same level of granularity versus these sort of techniques in red. So that is really important. It does mean, you know, as Shreen, all the points that Shreen made are almost kind of enhanced by that fact, is that all of these benefits come with the additional benefit and are sort of, you know, mutually reinforced by the benefit that you're kind of eliminating some trade-offs. It's actually going back to the title of this presentation, right? You can get insights without seeing the data. The point is the quality of the insights remains just as if you saw the data in the clear throughout the entire process. And that's a very important, you know, reason why you may choose to incur the costs of using these technologies, right? You may think to yourself, well, it's so much cheaper to just add a little noise, and now my third party charges me much less money to run the workflow. But it may be worth it if the quality of the results is something that has economic or health or other value for you at the end.
We have a couple of questions which are touch on what you guys have been talking about. One from Michael again, and thank you, Michael, for your questions. Is there any overlap between this approach and federated learning, which also strives to limit the sharing of data?
Yes, there is overlap. And in fact, vendors, like I mentioned, one Triple Blind, for example, I think in some of their materials, they advertise what they do, or one of the things they do as federated learning. So there's a couple of ways in which I'll probably give you too detailed an answer, but I'll try to break it into two parts.
We like detail.
Yeah. Federated learning is not, you know, I would argue is not exactly a well delineated term. So it could include, for example, taking encrypted data that's fully encrypted in the way I described, you know, at the maximum limit, and doing machine learning on that encrypted data using MPC, for example. And there's companies out there. There's another one like Duality, for example, that you know, is interested in how they have, I think, a $14 million DARPA grant to work on this. So there are companies working on doing machine learning on fully encrypted data, such that, and in some cases, even the models remain encrypted until they're delivered to the whoever's going to use them. So that kind of machine learning on encrypted data, which sometimes is called federated learning, depending on the details, because sometimes it's a little bit fuzzy where the boundary lies. And the benefits of that kind of technique, you know, everything I described, you know, about the strength of the blue techniques on that slide applies to that. Now, some techniques that are called federated learning, some of them don't really use any of those blue techniques. So they may do something like, for example, you train a model at one data set, and then you send that whole model to the second data set and train some more, and then you send it to the third data set. So in that way, the data all remains in place, so that you can certainly advertise this technique as keeping all data in place. Nobody's sharing their raw data with each other. And the machine learning model is traveling around learning that data. And sometimes, you know, that's kind of the other extreme end of things that sometimes people will call federated learning. And I think that's an appropriate way to describe that as well. So in that technique, I would professionally, you know, in my professional opinion, I would argue that is closer to the red techniques that we saw on that slide, because the problem is that it's hard to quantify how much a machine learning model leaks about the data that it's seeing. In some cases, you know, we've seen publications demonstrate, although there are caveats around how difficult it would be to do this. So I certainly think federated learning versus, you know, traditional, just put all the data in one place and run a machine learning model on it is better. The problem is just quantifying how much better it is. It is possible to reconstruct data from machine learning models. So if you're seeing machine learning models in the clear, then you may be leaking, and you may not be able to even figure out what you're leaking. And so it's better, but you should probably, at least, again, in our editorializing kind of manner that this presentation is in, and, you know, take it with a grain of salt. We're just one company in the space, and these are our opinions. But that sort of federated learning is closer to those red techniques. But hopefully you can ask the right question now, right? If someone comes in and says, we're doing federated learning, ask them, are they doing machine learning on encrypted data using something like MPC? Or are they doing sort of traditional federated learning where they're just passing models around and everyone end up seeing the model and potentially then may be able to infer things about the data from that model?
Thank you. We also have a question from Janice Karen. Poor data or bias in input data is a major issue. Does this approach or these approaches that you talk about have any added wrinkles in terms of addressing this problem or exacerbating this problem?
Yeah, it could
say to that.
It's both ways. So on the exacerbation side, obviously, if you can't see the raw data, and this is something we ran into. So we went to like the joint statisticians of the federal agencies back at the university and presented this stuff. And this is actually a question that they would often raise. If you can't see the raw data, then you can't do things like assess its cleanliness, assess whether it has bias. And there's many organizations, particularly in government organizations, that have very long traditions and well-established methodologies for assessing raw data before it's used to make policy decisions and so on. So a lot of those techniques, when you come present this technology to those kinds of audiences, a lot of these techniques seem to make things worse because essentially you're now keeping the data where it sits. The recipients of the data can't really examine it. They still get the outcome as long as you can write an algorithm for how to achieve that outcome, and therefore you can then run it on encrypted data. And so they raise that question. It's a very good question, and in general, yes, that introduces a problem because now you can't see the data in raw data, and you can't do that. Nevertheless, these technologies can help as well in that regard, because as long as you can implement an automated way to do the assessment that you're looking to do for bias, for cleanliness of the data, et cetera, now you can do that assessment without seeing the data. So as long as you can write an algorithm you trust, which again is totally acknowledged that that's a very challenging thing to do in many cases, writing an algorithm that will do the assessment you want about whether the data is biased. But nevertheless, if you can, then you can now run that assessment without putting the data at risk. And in that sense, it's a benefit. So you could either incorporate that assessment into the overall workflow, either to mitigate it or to maybe just throw up a flag and literally say, hey, this data doesn't look right. We're not even going to run the computation on encrypted data. We're going to stop right there, and everyone's data remains protected, right? So even though the data may not have been clean enough to produce a result, you've managed to not put anything at risk. All you did was make a one yes/no decision, and you said, no, this isn't good enough of a computation, not good enough of a data set. Let's regroup and figure out what to do next. So in that sense, it can be helpful, but it is a challenge to implement these things in a way that's automated. But I think what I would encourage in general, anyone looking at this is don't immediately dismiss it because it makes it harder to do that. Think about other places where this technology can help, maybe for a different piece, like doing preliminary assessments without putting things at risk.
Just following your last sentence there, Andre, I'm a healthcare provider organization. I have funds set aside to undertake a collaborative analytics program with a number of hospitals in the region, and I don't want to share their data, my data. I don't want to share my data in its native format. Obviously, I want to understand some of the issues that you've discussed today. Could you describe what might be sort of the scale at which I would want to start this? If I got together 5 business partners and said, let's start with a small data set, or let's start with a particular service area, or let's start understanding how we can start to share insights without giving our data out, without exposing data. What's the scale at which an organization should begin to experiment with this so that they can become familiar with it, they can introduce it into larger analytic efforts? But like George Carlin said, how do I get started? At what level is the first step an organization like a healthcare provider or a health plan might want to consider in looking at this kind of analytic effort?
I mean, our answer could be biased because we're a small company who offers these kinds of services. So we'll try to make it as unbiased an answer as possible. Realistically today, I think there's kind of 2 two ways that someone could go about that. They could go to the vendor first, find a vendor that, just pick one, not necessarily using any particular criteria. There aren't that many of them. We're one of them, and there's probably 2 or 3 others. Go to a vendor and basically learn about what the vendor is capable of doing. But as I mentioned before, vendors might not know what you need yet because it's just so early in that sense. So keep that risk in mind. But go to a vendor and see what they're capable of doing. They'll say, for example, look, we can do federated learning on tabular data that you have, and we have only the models we can do are linear regression and plus or something like that. So they could tell you their capabilities, and then you can assess whether that's something useful. But it would probably be a pilot, I think neither of my answers is going to be, all right, go sign up for a giant subscription to a giant platform, put all your data there, and then see what happens. That's probably not going to be a very useful, in any case, no organization would make that decision at this time in that way. So the other approach is to go the other way and say, what is it that we're actually trying to accomplish? So figure out first what the outcome is that you're trying to accomplish, as if you were willing to share the data. So, because if there isn't, the one thing we have as a challenge that we often face as a challenge when we're out there selling, is if it's unclear to the customer what the value is of the outcome that you're trying to achieve by running a computation on encrypted data, then it's going to be very hard to make the decision to pay the cost of running a computation on encrypted data. So it's really important that you understand and forget about just theoretically, because you think you're already interested in some kind of outcome. For a second, forget privacy. Just in your mind, just put it out of the picture. Figure out what that outcome is that you think is going to be valuable, and then with that use case articulated to at least the point of a diagram on a slide or something like that. Now go to a vendor and ask them. And today, vendors like us, for example, will be very receptive because we're interested in getting this technology out there. We want to know what the real use cases are, and we will be receptive. We will say, absolutely, let's look at your workflow. It's fantastic that you actually have one that you're already invested in. Let's see if we can make it happen. And now for the biased part of the answer from Nth Party, the reality is that once you've articulated that workflow and you can describe it, it may be very low cost for you to actually give it a try, especially for smaller data sets. So if you're talking about data sets that have less than 100,000 rows, for example, we at Nth Party, we can probably set something up where literally just using a browser-based techniques, and this is what we're known for, as Shireen described, that's how we started. Where basically everyone will just go to a web page, upload these, actually load it into the web page on your computer. You're not going to upload it anywhere. Encrypt it right on your computer, and then do the protocol between those computers. That's something that we built software for that runs in the browser. So no installation, probably don't even need to get your IT department involved. So in terms of, how the hardest part is articulating that workflow that's valuable to you. And then you can go to a vendor like us, for example, and probably don't even need to involve your IT department to actually run that pilot. So that's the end of the biased answer. I think we think it's a lot easier to do this stuff than some of the big platforms out there who will probably tell you, all right, you got to put all your data in our platform and subscribe. We think it can be easier, but regardless, those are probably, hopefully that gives you a range of what your options are today if you want to start exploring this technology.
Well, we at MHDC prefer these more loosely coupled architectures. Platforms make us nervous when we hear the term use. I'm sorry, Shireen, you were about to say something as well.
I was just going to sort of bottom line it. If there's a particular workflow that you've been wanting to do with partners that would help you either dramatically reduce the risk of sharing data in some other way, or it's a huge opportunity for a big social benefit, that's a workflow to pick off. But, to just sort of, again, bottom line it, pick off a workflow, a data transaction that would be high value in terms of, opportunity or lowering risk, and just get started with the one. The beauty of these technologies is that you don't have to implement them in a huge implementation in a pervasive way. You can just stand up a single computation in a matter of weeks. So keep it simple. And once you understand what it can do, what we have seen is people's imaginations start to take off in terms of other things that they would love to be able to do. They start thinking of all kinds of historical problems that could be solved. So once you get to one, it's easy to get to 10 ideas.
Thank you. I'm going to start a poll here. So while we have almost all of our folks online here, those of you who are online, please take a moment to respond to our poll. And let us know what you thought about today's presentation. Okay, the numbers are starting to come across the transom now. Let's see what we're seeing. All right, we're banging, banging, banging.
You didn't warn us about this one, Denny.
Oh my gosh.
Now we're nervous.
Penny. I feel like a product on Amazon.
You are. You're doing very well, though. I have to point out you're doing excellently. So,
Thank you. All right.
all right, we're going to give it just a second more. We have 19 folks who could do this, but many of you may not be at your computers, so we're going to give this another maybe 10 seconds. Please take time to complete the poll, and we will wrap this up. All right, here we go. Down to 1 second left. There we are. All right. Any final questions from folks in our audience or folks online before we begin to wrap up? I want to thank both of you. I think this is fascinating. I want to have you back and tell us, the first, one of these implementations that you can present to us as a case study. I think the idea of, I've always found it fascinating, the concepts of secret sharing. You don't have to go all the way back to Joseph Conrad. You can see it happening today in technology, and it's fascinating to see how people, data can stay where it is, and people can collaborate in generating insights from these data without having to move data around, which is one of the cardinal sins in data governance. So, but it's always a pleasure. We enjoy having you. We enjoy seeing the technological strides that you're making. We strongly encourage those of you in the audience to try this out. Look at a project. Look at one of the many projects that you have where you can sort of work right to left. What do I need to have in the way of an analytic result that requires that I work and collaborate with others, where the less I share my data, the better. But they need to be able to work with my data in a way that protects me and protects them. And this can open up a universe of possibilities when it comes to a health data ecosystem that is becoming increasingly federated and will become even more so in the coming years as patients have their health data on their device. They will be increasingly empowered to control how their data are used. And when you think about data in a federated world like that, offering services that allow, for example, patients who have a particular disease to share their data and know how others who share the same clinical circumstances that they do can share their information, and yet you don't have to give away anything about yourself in doing so. It's a fascinating concept. It's a fascinating technology. Its time is coming. You guys, we're not going to send you petabytes of data or come up with anything that would look like that. I think people need to step into this and start seeing it manifested, not only at smaller scale, but in shorter periods of time. The economics and the speed with which this can be implemented, especially when you focus on smaller projects, is a tremendous learning experience and a very cost-effective learning experience. So I encourage those of you in the audience who are considering, multi-party computation or working with other organizations with whom you'd like to share results but not data, to think about how this kind of technology can be applied. Shireen, Andre, I want to thank you again. It's always a pleasure to see you and hear how things are going at Nth Party. And with that, we came in just under 90 minutes, so we did pretty well today. So I thank you for your time. I thank our audience members, and we're adjourned.
Thank you very much for having us. It was great.
Our pleasure.